Okay, today's topic we are going to talk about naive Bayes algorithm. So in previous video, I actually did some calculation of the formula of Bayes algorithm. But in this video, I'm going to talk about naive Bayes algorithm. So what's the difference? Okay, so let's see this. The Bayes rule, this is in previous videos we were talking about. So the probability A occurring given evidence B has already occurred. So the probability of this one. So this one equals to given A, the probability of B happen, multiply the probability A occurrence and divides by probability of B. Okay, so this is basically the Bayes series. So we are going to do naive Bayes. So here, why we call it a naive Bayes, because we have some assumption. Okay, so the fundamental naive Bayes assumption is that each feature make an first independent. What does that mean? Independent means that this feature color, red color is independent with yellow. And also so yellow also independent with red color, something like that. The type is sport or SUV, they are independent. The origin, domestic or imported are independent. So all of them are independent. There's no relevance between them. Okay. And also there's another assumption is that they all are equal. They all are equal means that the contribution to the output, this car is be stolen or not, is equal. Red color, sport, cosmetic, so all of them, the contribution to this output is equal. So let's take an example to get some better understanding. Okay, consider the car is being stolen problem with the attributes. Attributes means like the features. Okay, so related with the color, type, origin, and the target. Okay, the stolen can be either yes or no. So we can say, hey, this one is yes or no, right? Something like that. This is an example. This is a very good example. Okay, so the data set is represented as like this. Okay, so concerning our data set, the concept of assumption made by the algorithm can be understanding like this. Okay, let's think about the independent and equally. Okay, so why it's called a naive. So remember, in the real life, the features actually they are related with each other. They are dependent with each other. Okay, it's really raw in the real life. It's independent of the colors. Like some people like red color, some people like a yellow color, but maybe black color is more popular, you know. And also we have an assumption, so each one is equal. The contribution to the outcome is equal, but in the real life, it's definitely not equal. But why we do the assumptions of this for this feature? Because even in the real life is not independent or is not equal to the outcome. But if even we do this assumption in the natural language processing, it still can get a good result. That's the reason. That's the reason. So that's the reason why we call it naive. Okay, let's understanding this. So we assume that no pair of features are dependent. For example, the color being red color has nothing to do with the type or origin. That means that the color can be red color And the red color can be sport car or SUV car, it doesn't matter. And the red color can be imported or domestic, it doesn't matter, right? So that means independent. So each column, each feature, they are independent. This is a assumption. Okay, that's the assumption one is independent. So secondly, each feature given is in the same influence, okay, same importance. Okay, for example, knowing only color and type alone cannot predict the output perfectly. So none of the attribute are irrelevant and assumed to be contribute equally to the outcome. Okay, so these assumptions made by naive bias are generally not correct in real-world situation. As I said, in the real world, it's always like happen that they probably have some, like if you have a sport fancy car, you probably like a red color, yellow color, or maybe white color, but not black color, right? So or maybe it's imported good cars from other country, not domestic cars, right? So yeah, it may happen that it's relatively in real world, but when we do the naive bias, we have the assumption they are independent. Okay, the independence assumption is never correct, but often works well in practice. That's why the name is naive. Okay, that's why it's called naive. So, that's the definition. So we need to classify whether the car is stolen given the feature of the car. So the column represent those features and the row represent individual's entrance. If we took the first row, the data set, we can observe that the car is stolen if the color is right. Okay, the type is sport and origin is domestic. So we want to classify a right domestic SUV is getting stolen or not. Okay, here is the example. Okay, so here is the example. So the variable y is a class variable, is stolen or not stolen. There only have two. Okay, so which represent if the car is stolen or not given the condition. The variable x, this is big X, represents the parameter and the features. The feature can be x1, x2, x3, like a color, if the type of car, and then the origin, right? The origin, yeah. So this is a different feature. So after we do, because we assume that all the different features are independent and they are equally to contribute to the output. So what we can do, we can predict if a car have given these features, we predict this one is be stolen or not. Y is stolen or not. Okay, and then see from here we can see this one, because they are independent, so they so py given x1 x and happen, so it will be like this, equals to given y happen, and then we have a pxy and given y p x2, because they are independent. Okay, and then they divide by px1 x2 x3. Okay, this this is the based on the independent and equally the assumptions. Okay, so basically this is a naive. Here's the table. This is a naive bias example. Thank you for the watching. I'll see you next time.